For the following exercises, state the domain, range, and X-intercepts and Y-intercepts. If they exist, if they do not exist, write D and E. So we're going to start with number 21 here. We're going to start with h of x equals the log base 4 of x minus 1 plus 1. Okay, so first things first. Now remember, domain is all possible x values. So when I look inside of this thing, what can I plug in for x is the question here. So when I talk about log functions, the log I'm looking for has to be greater than or equal to greater than 0 for the inside of my log. So I'm going to write x minus 1 is greater than 0. Now remember, I can't take the log of 0 either. If I think about the picture previously that I did in the last video, was this one here. And remember, the red function is my log function. And look at this, as I go towards 0, this thing is going all the way downward. So that tells me that it's going to be negative infinity there. Okay, so the idea then is, as I go towards 0, it's negative infinity. So I can't even have the log of that whole thing being 0. So it has to be greater than 0. So that's where that comes from. All right, so now when I add 1, I get x greater than 1. So that means my domain then is going to be 1 to infinity, because that's what that interval for that inequality is going to represent. So I would write domain 1 to infinity. Now let's talk about the range now. Now for my range, look back at the function here. Now this function has a vertical asymptote. All log functions do. And on one end, it's going to go all the way down. And then on the other end, it's going to go in an upward direction, not straight up. The other one's not straight down either, but it's more steep. But it's still going to go downward. Now, even if I reflected this over the x-axis, it's still going to go up and down. So I'm not going to be able to take that away from this. So my range is going to be from negative infinity to positive infinity. And if you think about it, the green one here is my exponential. And remember, exponentials and logs are inverses of each other. So this tells me then with the exponentials, the domain was negative infinity to positive infinity. And remember, when we talk about inverses, what happens is we just swap the domain and range, and then we get the other function. So if we think about that, if we're okay with the exponentials, we can simply say that, oh, the domain of the exponentials is the range of the logs, which means negative infinity to positive infinity. And that's always going to be the case there. So now let's talk about X-intercept. Now for the X-intercept, that's where my y equals 0. So remember, my h of x is my y here. So if I'm going to make that 0, I really have log base 4 of x minus 1 plus 1. So the first thing I would do here is I would move the 1 over. Okay, so this is going to be log base 4 of x minus 1 equals negative 1. And then I would do 4 to the negative 1 equals x minus 1. And all I did was change it into my other form. Okay, and then from here, I would add 1 to both sides. So remember, this is 1 over 4 to the negative 1, and then I would add 1 equals x. So that would actually be 5/4 equals x. So that's my x-intercept. So my x-intercept then would be 5/4, 0. All right, so there's my x-intercept. Now let's talk about the y-intercept. So then for the y-intercept, my x has to be 0. And that just simply means I just have this y equals, for my h of x, of course. And that's my log base 4 of 0 minus 1 plus 1. And then if I simplify this on the inside here, I'm going to get y equals log base 4 of negative 1 plus 1. Now this is a problem here because I can't take the log of a negative number or 0. Remember, whatever I take the log of has to be a positive number. So therefore, this would be undefined. That's what that would result in. So what that tells me then, for my y-intercept, it's D and E. And now if I think about the graph here, just think about my graph in general. Okay, so if I have my regular log function, it's this. And then first off, this here is saying, hey, well, let's talk about the inside first. First there is saying shift to the right one. So I'm going to take my graph and move it to the right one. And then it's telling me to shift it up one. So I take this same graph and now I shift it up one. And this gives me an idea of what we have from this. Now this is a terrible picture, but the idea makes sense here that y, I would get a D and E for my y-intercept. I'm actually moving to the right, further away from the y-intercept to begin with, which means my graph is never going to cross it because I have a vertical asymptote there, and I'm not going to cross that vertical asymptote. So that's how that works. So if I can think of the general picture, that helps a ton with these when I think of the domain and range and the X-intercept and Y-intercept. When I find that information, it should be very confirming and actually just makes sense. All right, so anyways, let's move on to the next one then. Next one's become easier because as I think about these problems here, there's nothing that is really much different. So then for my domain for the second one then, I'm just going to take that 5x plus 10 greater than 0 because that's what's inside of my log there. And remember, I can't take the log of a negative number. So I move the 10 over and divide by 5. So x is going to be greater than 2. So, in a sense, what we're seeing here is that shifted to the right 2. And the way to tell is if I factor a 5 out of that, I have x plus 2 left. Uh-oh, hang on a minute here. And then that means that should be a negative 2 then. Okay, good call. And this is what I mean by this information complementing each other. Because what's going to make that 0 there is negative 2. So when I move that 10 over initially, I made it a positive, but it should be a negative 2, which makes sense. And that's usually why when I look at those, I look at some other information just to correspond with the information I already have. So my x has to be greater than 2 because I'm going to move that over. It's going to be minus 10 divided by 5, excuse me, and then I get 2. So my domain then is going to be negative 2 to infinity. All right, cool. Okay, now let's talk about the range. So for the range, that's going to be negative infinity to infinity because it's a log function. And then X-intercept now. And that's where my y equals 0. So that's where my f of x is going to be 0. So that's log base 5, 5x plus 10 plus 3. So I move the 3 over to the other side, so it's a negative 3. So I have log base 10 of 5x plus 10 equals negative 3. And just remember that too. When I don't see a base there, it's understood to be 10. So this is going to be 10 to the negative 3 equals 5x plus 10. So this is 1 over 1,000 here. That's what that is. Equals 5x plus 10. And then what I would do from here is move the 10 over, which is going to be a negative 10 then. Now this 10 on this side would really be 10,000 over 1,000. So when I move that over, that's going to be negative 9,999 over 1,000, and that would equal 5x. Divide by 5, and that would be negative 9,999 over 5,000. equals x. So then the answer then for my problem there would be negative 9,999 over 5,000, 0. And that would be my x-intercept. Now again, remember my y is 0 for any x-intercept. Okay, so now moving to the y-intercept. Okay, that's where my x is 0. So then I would get y equals log base, really 5 times 0, so I'll just write it, plus 10 plus 3. So then that's going to be y equals log base 10 plus 3. And log base 10 of 10, what does that mean I'd have to do? I actually have to work that out. So that would be, and I'm going to write this equals y. So then that's going to be 10 to the y equals 10. So then I can say y equals 1. So y equals 1. And as we get used to these, what we'll see here is when the base and the base of what I'm taking of the inside are the same, those cancel, and I just have the exponent left. And eventually, hopefully, you get to that point. That really helps a lot. So I know that this then is going to be 1. All of this here is 1. And that's plus 3. So that tells me I get 4. So my y-intercept would be 0, 4. Okay. So now let's move to the last one, 23. So 23 here is g of x equals ln of negative x minus 2. So again, we start with the domain, and that's all possible x values. So it's where negative x is greater than 0. And then what I get is x has to be greater than 0? Not quite. I would have to divide by a negative, and when I divide by a negative, I have to flip my inequality. Oops, let me move that out of the way. So when I divide by a negative 1, divide by a negative 1, it flips my inequality. I get x less than 0. So when that x is less than 0, that means it's going to be negative infinity to 0, not including the 0. So it's going to go that way now. So that's going to be my domain. Okay, now for the range. Now for the range, that's negative infinity to positive infinity. It doesn't change. My x-intercept, that means my y is 0. Okay, so then I make that 0, so I get 0 equals ln of negative x minus 2. So I move the 2 over, 2 equals ln of negative x. And remember what ln of x is. It's really log base e of negative x is what I'm really looking at here, and that's 2. So this is really going to be e squared equals negative x. And all I'm doing is using that property, but I just got it written the other way, so hopefully it's not too confusing for you. If it is, write it the other way, if that helps. But that's just using that equivalent property again. So my x equals negative e squared. So now, for my answer then, I get negative e squared, comma 0. Now let's do the y-intercept. So for the y-intercept, that means my x is 0, so I just plug in 0 for my x. So that's going to be y equals, and then that's going to be ln of 0 minus 2. Now this is going to be undefined because remember, I can't take the log of a 0 or anything negative. Once I plug that x value in for it, whatever I have in there has to be positive in order for me to take the log of it. So right away I'm done with this one. So it's good for me to understand the boundaries of the log functions. So this would be does not exist. All right, so there's my answers for all three of these here. So hopefully that helps.